Hello. So in this video tutorial, I'm going to show you how you can create custom maps using Lidar data that Washington State provides. Using this data, you can create very high resolution topo maps. The Lidar data is extremely precise. You get very accurate height map data. So just backing up a little bit, what is Lidar? The data that's collected here, this is actually what they do is they fly planes on survey missions. And on the bottom of this plane, there's a laser scanner, and they actually scan the ground. And then using high accuracy GPS, they can use that to create a very accurate height model of the ground. So the Washington State Department of Natural Resources, they have an effort to scan the entire state. As you can see, there are still gaps here where they have not yet imaged. Kind of frustratingly, some of the gaps are kind of around some of the more mountainous peaks, which is kind of frustrating from a hiking perspective. But you can see they have some interesting areas they do have coverage for, like around Snoqualmie Pass and around Stevens Pass up here. So we can use that data to create these sort of maps. So one of the interesting things about this data, if you look on the left here, these are all projects. So all of this data was collected at different times for different reasons. If you hide this, I can show one specific project, for example. So there's this 2020 project they did to survey the Snoqualmie Middle Fork. You can see they scanned basically the entire region there, the entire watershed. So one theme that you'll see in some of these projects is they're trying to image an entire watershed. I guess they want that in order to have good forecasts on how much water will be available and things like that. You see a lot of these projects are scanning near transportation, like near highways, because they want to have good models for avalanche predictions and that sort of thing. So it's really focused on population centers and things for scientific value. So each of these projects actually have this metadata link here, and if you click on that, it'll actually give you a PDF file. So, like for example, this is the one for that Middle Fork survey, and you can actually look at this, and you can see that they have a whole bunch of information about the area they scanned, why they did it, very extreme details on their accuracy and their methods used and things like that, where there might be noise and things in the data set. So it's kind of interesting read, and you can see more information about what they collected and what the motivations were. So in terms of the data available, there's two data sets here for this project. I'm just going to focus on the Snoqualmie Pass area. This is Snow Lake, just north of the pass, popular hiking area. So we have two layers here under this project. We have the DSM and the DTM. The DTM, that's digital terrain model. This basically shows the ground level. So in terms of the LiDAR, you have this plane, it's scanning the ground. The light's shining through the trees. The longest distance the laser goes, the last return on the ground is what this shows. So you're getting the terrain that's free of vegetation. Basically, this is just showing the surface. Just showing the terrain. On the other hand, the digital surface model is showing the first return. So that's as the laser's coming down, it reflects off of the branches of the trees and returns that way. So in this case, you're seeing all the vegetation. So that's kind of the biggest difference. The DSM shows the vegetation, the DTM does not. Okay, so enough talking about LiDAR. How do we actually turn this into maps? So first thing, you want to download the DSM and DTM for the data set that you're interested in. We want the raw DSM and DTM. The hill shade is kind of a nice way of viewing it like this, where you have this shading effect, but we really want the raw elevation data. So if you download those two data sets, you'll end up with them in these folders like this. So the data is split into chunks, and these are actually TIFF files. So these are images. If you open this, you can actually see what this image is. Your photo editor isn't going to make much sense of this. It's mostly white, but it represents one chunk of the map, and so that Middle Fork survey is split up into these 30 chunks. So this brings us to the software we're going to use to create the map. So there's this software called QGIS. This is an open source GIS tool. So you can kind of think of this as like Photoshop except for maps. You can add this kind of geographical image data. You can compute contour lines. You can do a bunch of processing. You can change the colors, that sort of thing. It's like complete control for mapping data. There's entire jobs and professions revolving around GIS software, and I don't pretend to be an expert here. I'm just a hobbyist, so I'm sure there's other people who know this much better than I do. But I'll just show you the basics of how you can use this to create our map here. So once you install this, you can open a new project. So the first thing we want to do is load in that DTM that we were talking about, that digital terrain model. So if we go to layer here, we can add a layer, and we can go to raster layer. So a raster layer, a raster is just pixels. So it's a big grid, where each pixel on that grid corresponds to a height value. So let me show you what that looks like. If I load the file here, I can go to that project that we downloaded before. I can go to the DTM. I know grid 8 here is that Snow Lake grid, so I'll pull that open and I'll add the layer. So it's a little hard to see here, but I'll just explain what we're looking at. So this blob right here is Snow Lake. This image is a raster image, so it's X number of pixels by Y number of pixels, and each pixel has a height value, and you can actually see that here. The height of this raster layer ranges from 1,400 feet here at the bottom, and that's basically everything that's close to 1,400 feet is being displayed as black. And then the highest value in our image here is 6,256 feet, and that's going to be white. So you can see the crests here of the peaks are white. Now, this isn't too useful as a way to view a map, but we can use this to as a starting point for computing some more interesting data and kind of building up our map. So first step, let's use this data to compute contours. So we can compute all the points in this image that have the same height and then connect them by lines, and that's how you get contours. So on the right-hand side here in this processing toolbox, there is a contour raster extract. So we can extract contours from our raster image here. So if I open this, I can select this DTM layer that we just did. I'm going to use the default for 10-foot distance between contours. I'm just going to hit run. That's going to go through this raster image and do that computation where it finds all the lines such that you get those equal elevation lines. As soon as this completes, we'll have contours drawn. This is going to be an absolute mess, as you'll see here in a second. Now my layers here are reversed, so I'm just going to drag this up to the top so that we see the contours on top. And you can see here we have contours. It's awfully messy though, because we're seeing every single 10-foot contour on the map here, and there's no labels, there's no bold lines or anything. So we need to apply some styling here so that we can actually make sense of this, actually turn this into something that looks more like a topo map. So if we go to our contour layer, if you right-click it, you can go to Properties. There's a whole bunch of options in here for how we want to style things. As a first pass, let me just zoom in a bit more so we can get some more interesting results here. So I'm gonna go to Properties, and I'm going to go to symbology, and you can see this controls how thick those lines are. Now, we can do this a couple different ways. One way that I've found you can do it, if you go to width here, you can actually use a custom expression here. And I can say if the elevation of the contour line, and I can say modulo 100 equals 0. So basically, if the contour line, when you divide it by 100, there's no remainder. So basically, the contour is evenly divisible by 100, like it's a contour that represents a 100-foot index. If the contour line matches that condition, I'm going to have that the width of that line be 0.5. Otherwise, it'll be 0.25. And just by doing that, you'll see here now we have those thicker contour lines for every 100 feet. So that's getting closer. As a next step, let's say we want some labels. So we of course want to know, what the contour lines actually mean on our map. So we can go to labels here. We can go to single labels. If we just apply this, this is going to be a mess. We're going to get a label for every single contour on our map. So we don't want to do this. We want to go to rules-based labeling. And I'm going to actually remove this here. I'm going to go and add a new rule. First, we need to say what contour lines this rule should apply to. So again, we're going to use this expression, elevation mod 100 equals 0. So that means the elevation is evenly divisible by 100. So we're only going to show those labels on those 100-foot index contours. And I'll just call this index contours. For the value, we also want to use this expression elevation, ELEV, that will draw the elevation on each contour line instead of something else. So if I click OK here, this should give us what we're looking for. So you can see this is looking okay. We have contours, and we have one contour per index contour. There's a couple things I want to fix here, though. One thing we can do to make this look a bit better, if we go back to our rule, we can turn on buffer. So that just draws a white border around all these labels, makes them a little bit easier to see, as you can see here. We also might want to change the placement. You can see right now these labels are on top of the line that they represent. However, we can actually change that. We can say instead of on top, let's have them appear on the line. And so I did that, and now they're directly drawn on top of the line they represent. Lastly, I'm going to turn on repeating. So you can see here, these contours are only shown once on the line. So this 4,000-foot contour, it's just here for the label and nowhere else on our screen. In practice, you'll probably want the label to appear every so often, so that if you're scanning the map, it's a little bit easier to find where that label is. So we can do that. We can go back to our labels here, and we can turn on repeating labels, and I can have them repeat every 100 millimeters on the map. And if we do that, you'll see that looks a little bit better. We have labels every so often. And you can of course adjust this to taste to get the contours you're interested in. So I'm going to just apply a style here that I worked on before. So this does pretty much what we were talking about before. It changes some of the colors. There's also some things in here where if you're zoomed out, like this view right now, it drops it to 40-foot contours with indexes every 200 feet. So this is more what other maps would show. But then if you zoom in, it starts showing more contours. So I just found this works a little bit better. Again, this is just playing around with those rules to get it to draw what you want it to. I also had it when you're very zoomed out, the contours kind of get more transparent, and they eventually just fade away. And it just helps with the display, so they don't clutter up the screen when you're zoomed out, and they're not as meaningful. Again, you can play with the style, get it to look like what you want. So that's contours. Let's talk about the background here. So right now we're just viewing the height data. This isn't too meaningful though. What you probably care about is slope shading. So the slope at each point on the map. So we can do that using there's a slope shading computation. So I'm just going to disable the contours for a second. If I go to the raster terrain analysis slope processing item, I can open that up. I can use our DTM, and then I can click run. And this will go through that raster image and give us a new raster image. So you'll see we now have this slope layer. You can see already it's much easier to see the terrain here, but I just want to explain what this means. So the black values on this image correspond to 0 here. So that's actually 0 degrees. So you can see, of course, the lake is completely flat. It's completely black, so that makes sense. We can also see the white here represents 88 degrees. So if it's pure white on here, it's a complete cliff. So this is getting close to what we need. However, we probably want to style this a little bit differently so that it's a little bit we have a little bit more color here. We can go to properties, and if you go to symbology, you can change the render type to pseudo color. What that means is we can actually apply some rules on how to color this image. So I'm just going to add 2 of them. So I'm going to say if it's 0 degrees, let's make it, I don't know, dark purple or something. And if it's 90 degrees, we're going to make it bright yellow. And I can apply that to my image. Oh, sorry, 90 degrees. So 0 is dark purple, 90 degrees is yellow. And we get an image that looks like this. We can play around with this some more. Let's say maybe we want 30 degrees to be this kind of dark purple color. But then 0 degrees is going to be green or something like that. And we can kind of color this image to represent whatever makes sense. So I'm just going to load the style that I've computed before. So this style kind of mimics the Topo way of styling layers, where it starts showing slope shading at 27 degrees. Your kind of peak avalanche terrain is red, and then as you get to blues and blacks, it's more cliffy areas. So I can apply that rule, and then you can see here we have pretty good slope shading. I can combine that with contours. Let me just uncheck the DTM because we don't need to see it anymore. And already this is starting to look like a topo map. We have pretty good display of the terrain here. You can also play around with the slope layer with rules and things. I have this once you start zooming out, it gets more transparent. I just found it makes it a little bit easier to read things when the map's zoomed out. So that's pretty much the slope shading layer. Let's talk about the overlay layer. So right now we don't have any indications on this map where trails are, where peaks are, that this is Snow Lake. It's just purely terrain data. So what we can do is we can add a XYZ tile layer. So if I go to layer, I can go to add layer, and I can go to XYZ layer. We can then add a new connection here. Now the one I'm using here, if I click edit, you can see what this is. I'm using this address. So this is actually the Topo map builder tile server. So I mean, this is getting a little bit into the weeds here, but the way this works is each section on our image is represented by a zoom and then an X coordinate and a Y coordinate. So if we're really zoomed in, it might be zoom level 19 and then a specific tile. So it just hosts a whole bunch of PNG files, and it'll load the sections of the map that we need. So if I put in this layer, and again there's many tile servers out there. You want to find one that works, but I can use the Topo map builder tile server, and I can add it. And just that easily. We have this this Topo layer on top of our map here, and this is showing where the lake is, where our trails are. So that's a good way to see what's going on. I guess the last thing I want to talk about that I have in my map here, I have these trees. So we talked about before how there's this surface model and this terrain model. If we go back to QGIS, we can load in that. So right now this is just a terrain model. I can add in another raster layer, and I can select the surface model. Again, this same number 8 that we loaded before. So now we have 2 layers in here. I'm just going to pull both of these to the bottom. We have one layer here for the surface model, one for the terrain model. If you actually look at these, there's not much difference because these 2 images are very close. Just mathematically, this is showing feet above. It's showing elevation, so the surface model is only going to be 100 feet above the terrain. So you're not going to see much from this by itself. But what we can do here is we can use the raster calculator. So I'm going to go to raster. I'm going to go to raster calculator, and this allows you to do a mathematical computation. So I can literally I can say, show me the surface and subtract the terrain. So this will be the only thing that's left over is how many feet above the terrain each point represents. Now this would work. I found that what you probably want to do here is also take into account the slope. So we have this previously computed slope layer, and I'm going to say if the slope is greater than 50 degrees, just treat it as 0. Otherwise, we're going to use our height. And the reason I'm doing this is because the surface model starts to have some issues on very steep slopes. If we don't see this, we end up with trees showing up on cliffs where they clearly couldn't be. So instead, we're just going to say if it's a steep slope, we don't display anything. Otherwise, we'll show the height of the surface above the terrain. So in this case, we need to save this to a location. So I'm just going to put it as this surface.tiff file here. And this should be fine. I'm going to click OK. It's going to go ahead and compute this. Okay, so that's done. Now you'll see we have this this new raster. So this is the surface model that we just computed. So this is, if we expand this, we can see it goes from around 0 to 230. So the most white points on our image here are basically trees that are 200 feet tall, and black is there's nothing there. So once again, we can edit the style for this layer. We can go to symbology, we can apply our pseudo color, and I'm just going to load the one I did previously because it's pretty simple. Sorry, that's the wrong one. Vegetation. So in this case, I'm saying if it's less than 5 feet, just make it transparent. At 30 feet, we display this bright green, and at 100 feet, we display dark green for the really tall trees. And that gives us what we want. This is a layer that represents kind of how much vegetation there is in each location. So let's stack all these layers on top of each other. So at the very bottom, I want the slope shading. So I'm going to turn that on. Right on top of that, we want this surface model for all the trees. Let's throw on our contours. And lastly, we'll put that overlay on top so we can see the names of all the trails and things. And that is pretty much how I got to this map on my map server. There's a few more details. I'm not going to talk about them too much in this video. We just looked at one map tile here. So this is one section of the data. In order to compute larger maps, you need to join all of those files together. There's something called a mosaic So there's tools that you can do that to combine these larger data sets. At some point, though, you start running into to memory issues. This section of Snoqualmie here eats about 32 gigabytes. When I was trying to compute it, I was running into memory issues. You can try to chunk things up a little bit better. It's tricky when you try to compute a large data set. There's also the question how to actually export this data. There's a couple options here. What I did is I generated XYZ tiles. So what that does is I can actually, like we were talking about that tile server, I can chop this map up into a bunch of little PNG images that are 256 pixels by 256 pixels, and I can generate those images at various zoom levels. I'll just show you what that looks like quickly if I go to this tile server. So I have a directory for each of these zoom levels, and this is my x coordinate, and the image name is the y coordinate. And if I just look what these are, each image here is just one little chunk of the map, and then this map viewer basically knows how to load all of those different little mini images in order to display this nice map, and you can just put that behind a web server, and you get this sort of map. There's a bunch of other options you can do with QGIS. You can print these out as PDFs. If you save this as a GeoTIFF file, you can load it in something like a Venza viewer in Android. There's several options. In any case, that's all I have for you today in this tutorial. Happy hiking.